All right, let's talk about fun with loops, conditionals, and functions. So let's jump into loops. The first thing to note is that loops allow you to run the same code repeatedly without retyping. The main functions for writing loops are for and while loops, though there are certainly others. It's important to point out that you make good use of spacing and tabs to keep your script well organized. That is, make sure that you understand when you're in a loop and when you're outside of a loop. The best way to do that is with good spacing. So here's the pseudo code. The syntax for the for loop says for value and sequence. I'm going to run some code. So I'll set the value equal to the first element of the sequence, run some code, go on to the second element of the sequence, run some code, and so on. The while syntax asks for a logical. So basically, you'll input a logical or a statement, and if it's true, then you'll run some code. So let's look at a simple example. So let's look at the for loop. Remember, the pseudo code is value in a sequence. So let's look at the value I in the sequence 1 through 10. So we'll have an open bracket. Notice I have a space here so that I know when things are inside my bracket and when they're not. You can put the bracket right after the for if you want. And so you can actually put all of this on one line of code if you really wanted. I just like to do this to keep organized. It's just the syntax that I adopt. So for I in 1 through 10, I'm going to run the code print paste this is line, and then I'm going to set the value of I equal to 1, 2, 3, and so on. And this is what the result is. So for example, start by setting I equal to 1, run this code. Then set I equal to 2, run this code. Set I equal to 3, run this code, and this is what you get. Let's look at running similar code with while loop. So while, so first of all, let me back up. First of all, we need to set I equal to something so that when I run while I is less than 10, this needs to take on value true or false. So if I wasn't initialized, you'd get an error here. It wouldn't know if I was less than 10 if I doesn't exist. So I had to create the object I and set it equal to 1. Now what I'm going to do is this. Just run the code and I'll go back and show you. So while I is less than 10, print paste this is line I. So I started off being 1, so 1 is less than 10, so that conditional takes on value true, so we'll run all of the line inside all the code inside the loop. So I is equal to 1, print this is line 1. And now I'm going to add 1 to I and then go back and check again. So now I takes on value 2. 2 is less than 10, so that conditional takes on value true. So I'll run all of the code in here. Now I will be 3. Go back, go back, go back, and run the code. And the second I is less than 10, the code stops running. Or the second I is greater than or equal to 10, the code will stop running. And that will happen here. So we'll say this is line 9, and then we'll set I equal to 10, and it goes back up and says, is I less than 10? The answer is no, so it never gets to print this is line 10. Okay, so let's just slightly modify this loop to print 1 through 10, just to understand the order of operations here. So now I'm going to initialize I to be 0, and I'm going to say, is 0 less than 10? The answer is yes, so I'll add 1 to I. So now I will be 1, and I'll say, print, this is line 1. Go back up. I is 1, which is certainly less than 10, so change I to 2. Print, this is line 2. go back up. 2 is less than 10, so I'm going to change I to 3 and print this is line 3. And what's going to happen, I'll get down to line 10 and I'll stop. Okay, so here, when I is 9, I'll add 9 to I, print this is line I, so this is line 10, and then when I go back up, I'll check my conditional again and I will not be less than 10. Okay, here's a little more sophisticated example of for and while loops. It's a little more sophisticated example, but very useful to have a loop to generate a random walk. So here's what I'm going to do. I'm going to set the first value of my sequence in the random walk equal to 0. And what would I want to do? I want to generate a new value. And how was this guy generated? 1.51 was sampled from a normal distribution with mean equal to 0. And then I created a new vector and I stacked, which stacks this guy next to it. Now what do I want to do next? What did this do? Now here's where I am in the random walk. I'm at 1.57 and I want to generate a new realization where now the mean of my random normal distribution is 1.519. The data that I get is 1.8867 and it's stacked on to the end of my x vector. Right, so I could do this again. Now I'm generating 3.58, was generated from a normal distribution with mean 1.88, and then I stacked it on to the end. So you can imagine if I wanted to generate a random walk of length 500, this would take me a long time to type all this code. So I'll use a loop. So you'll notice, let me just run the code, and then I'll go back through and explain it. So here, I'm just initializing x as before, and I'm generating a plot, adding a nice label and a horizontal line at 0, and then here's where I run my loop. So you'll notice this line of code, x, concatenate x, and I generate a new random variable from a normal distribution where the mean is the current end of the sequence. So when I is 1, what am I doing? Generating a normal random variable where the mean is x of 1, which is 0. Stacking it onto the end, so now I have a vector of length 2, and I'm going to add those points to the plot. Now I'll take I is equal to 2, I'll generate a normal random variable where it has mean x of 2, so whatever was previously generated. When I is equal to 3, I'll generate a normal random variable I'll generate another normal random variable, and the mean of that variable will be x3, and so on. So this is the end result. So if we scroll up, first value in the sequence is 0. Then I generated this guy. It was generated from a normal distribution with mean 0. This guy was generated from a normal distribution with mean 0.64. This guy was generated from a normal distribution with mean negative 1.04. This guy was generated from a normal distribution with mean negative 0.39, and so on. And I just did this 500 times. Plotted the data, here it is. Now, what if I just wanted to generate a random walk until something happened? Specifically, I want to look at a random walk stopping time. That is, I'm going to start with x is equal to negative 10, because why not? I'm going to open up my plot. And I'm going to set seed here to make sure that I've made sure that this random walk will stop. So here, this is all just plotting code. Added a horizontal line. This is going to be my stopping time. Set my seed, And now I have this while max of the vector x is less than 0, and I'm going to do the same thing. I'm going to generate normal random variable from the last element in my sequence. That's how I'm going to set the mean equal to the last element in my sequence. So currently, for example, if the length of x is 2, I'll generate a normal random variable and use the second element of my sequence to determine the mean. And then I'll stack that next to it to get a third sequence of length 3. So I keep running this code over and over again, just adding some more plots. And here's what happened. It kept on executing this code until the max of x was no longer less than 0. And that happened after about 70 iterations. What if I run this again? I would need to initialize x and run all of this code again with the seed different. Might get very different results. So here I sampled and it took me until over 200. The length of the sequence was over 200. So here the key is I have to use a while loop because I don't know how long it's going to take me to get to the maximum of the sequence being. Okay, let's talk about conditionals. These allow you to run code if a condition is true. You can also use the if-else is good for vectors, or just if is good by itself for non-vectors. So the pseudocode here for the if-else is this. I'm going to check to see if a condition is true. If it is true, I'll execute whatever code I have inside these two brackets. I can add an else statement so that when the condition is false, it'll run this line of code. You can actually leave this part off too, though. You don't have to have the else statement. Here's the if-else function. It says check for a condition, and condition can be a length, can be a vector, for example. So that's when this is useful. And for each element of the vector, when the condition is true, it'll execute lines of code. And then for each element of the vector, when it's false, it'll execute the lines of code after the comma. So no brackets here, all just one long function. So here's an example. I'm going to set x to be 6, and I'll run this code. If x is less than 5, print x is less than 5, the condition is true. So you can guess x is not less than 5, it has value 6. So this code is going to be ignored until it sees the bracket here. So now because x is not less than 5, it will run this code that says print x is not less than 5. The condition is false. So it ignored this code because the condition was not true and ran this code instead. Let's try it just to hammer home the point. Let's take x to be 3 and run the exact same code. Now what happens? X has value 3, which is certainly less than 5, so it ran the code for the condition. Because the condition was true, it ran the code inside the first set of brackets. So here's the if-else. This will show you that you can apply if statements to a vector. So x is 1 through 10. I'm going to set my value of y to be a new vector, which will return small or large. It will return small whenever x is less than 5, and large whenever x is not less than 5. Okay. So what does y look like? Small, 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 small. When it's less than 5, large, 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 for all of the values of x where it's greater than 5, greater than or equal to 5. Let me just do a practical example. Let's load the roster data from last class period, attach it, and I already attached it a few times, so I can detach. It won't hurt anything. I can detach if I want. There we go. I'll attach. And here, remember I have this object called grade, BADFDCFABC. First of all, notice that this is a character, and I might want this to be a factor for later analysis. It's useful if it's a character for other reasons. But I'm going to check to see if grade is a character. So this will return true for character. And so if I put the if on one line of code, I can avoid the brackets. So this runs the same thing as bracket. So if it's all on one line, it will insert the brackets and there's no else. Okay. So similar code. So now, if I run grade, now I've changed this to a factor. I can do something like this. Suppose that I want to check to see, what is this doing? This is going to check to see if grade is not a factor. So remember, this is not the exclamation point. If grade's not a factor, it'll save it as a factor. Else, if it is a factor, it'll print grade is already a factor. So what's it going to print? I just changed grade to a factor, so it'll print grade is already a factor. Another example of the if-else. So here I'm going to run if-else on the score. So let's see what score was. These are our scores. So I'm going to just assign a pass-fail grade of pass if score is greater than 5. So here is my if-else statement. So you'll notice if I save outcome, so what am I doing here? I'm running if-else, and you'll notice when I run if-else score greater than 5, print passed, print failed, it's actually going to run the possible outcomes and print them to the console, and then apply the if-else statement to each element. So to illustrate that this is just printed to the console and not actually saved in the workspace, you'll notice if I run outcome, if-else, this is the same code, but I'm saving the outcome as a variable outcome. It'll still print passed, failed, the possible values of outcome to the console, but it won't save them to outcome. So passed, failed is all that's actually returned to the workspace, so to speak. So each potential execution of code is printed, then the code is actually executed. So it's printed, but doesn't actually get saved to an object. Okay, let's talk about functions. So you can create your own custom functions, which will allow you to run bulks of code and pass different parameter values to the code. So objects created in your function aren't saved to your workspace, so this is the most common misunderstanding, so I want to point that out off the bat. Make good use of spacings and tabs as before. And I want to remark that a package is really just a collection of functions that somebody created that you can load later and then use. So if you create a bunch of functions, you can put them in a R script, and basically what you've done is create a package. Below, you may or may not set default values for your parameters in your functions. So just like when we read the help file of functions, sometimes there is mandatory input, and then sometimes there's optional input, and that's because a default value has been set. So here's the pseudocode. I'm going to create a function called myFunction. How I create it is with this function. So this is a little tricky. So I'm going to save an object called myFunction, and here is how I'm going to create the actual function. So here I'll have my parameter value 1. It can take on a default value, so I can set a default value. Parameter 2, I didn't set a default value, so to run the function that I'm going to create, I have to pass parameter 2 to this function. So open bracket, this is the code that will be run within the function. Some code here, and then the last line you can write return my output. So you're going to do some code to generate my output, and then hit return my output, close bracket. And then once you've created the function, now my function will exist in your workspace and can be ran. So I can run this code with different parameter values without having to retype it all or copy and paste. So let's do an example. So I'm going to create a function called get.confidenceInterval. So this is what I decided to name it. And it's going to import data. So notice I don't have a default value for data, so it requires that argument. Plotted is going to take on default value of true, and alpha is going to be the level of my confidence interval. The default value is 0.05. So the first thing I want to do is plot it is an option. So what's going to happen here? If plotted is true, I'm going to run this code. So by default it will be true, and what's this going to do? It's going to generate a simple box plot of the data and a QQ plot of the data, which we'll talk more about later. The important thing is I have some code here that's ran inside the if statement when the value of plotted is equal to true. Then I'm going to go down to this code. What's x bar? That's the mean of my data. What's n? The length of my data, or my sample size. Degrees of freedom is n minus 1, and now I'm going to make, to get the margin of error. So this is qt, alpha over 2, degrees of freedom, lower.tail equals false. So this will get the upper teeth quantile when alpha, for alpha over 2, using the degrees of freedom up here. And then I'm going to multiply that by the standard deviation over root n. So this is the formula for the margin of error for a t interval. And now I'll actually create my lower and upper limits, x bar minus mo, x bar plus mo for lower and upper. And I'm going to create an object called interval that is set to lower equals lower, upper equals upper. So the value of lower is equal to this value computed up here. I'm naming it lower on the fly. I'm naming upper, and it's going to take on value computed up here. And lastly, I'll return interval equals interval. So you can just have return of interval, but I wanted to name it interval also. All right, so recap the bigger picture. I have my data that's an input, plotted an input, and alpha is an input. Plotted and alpha have default values. So by default, I'm going to plot the data, and then I'm going to go through this code that makes a confidence interval automatically. Where is alpha coming into play? In the t quantile here, alpha over 2. And I'm going to return an object that I created called interval. So let's run this. So here's some data, x, and I'm going to run get.confidenceInterval. Recall, I have to input data, so my data equals x, but I don't want to plot it, I just want to get the confidence interval. And the default value for alpha is 0.05, so here's my here's my confidence interval for x. Notice now I can also I get the same confidence interval, But now I want to set alpha to 0.2, so I'm going to make an 80 confidence interval, and I want to plot the data. Plot it. Remember, makes a QQ plot and a box plot. So I told it plot it was equal to true, so it ran this code on my data X. So what exists? So X exists in my workspace, but my data doesn't. That's just what I named my object within the function. Plot it, while this code is being ran inside the function, certainly exists, but it doesn't exist in my workspace. Margin of error doesn't exist in my workspace. Alpha doesn't exist in my workspace. All right.